Namaste and good morning to you all, and also welcome to another session of online mathematics class. And in the previous sessions we have learned some operations, matrices, and also we have learned how to find the transpose of a matrix, and we have solved some applications of transpose of matrices. Hope you have revised well. Now let us start the session with an example of a matrix. Here there is a matrix 3 by 3 order. There are 9 elements, and let us take the transpose of this matrix. So when you take the transpose, a transpose, first in the first matrix 3 minus 2 4 is in the first row. In the transpose it will come it as the first column, and here minus 2 6 2 will come here as the second column, and the third row in A, that is 4 2 and 3, will come here in A transpose as the third column. So we have taken A matrix and we have written A transpose. Now when you closely observe A and A transpose, it is quite clear that both the matrices are having the same elements. 3 here, minus 2 here, minus 2 here, and you see 3 on the last element here also 3. So when you check, all the elements are same. Since all the elements are same, we can say that both the matrices are equal. That is, A transpose is equal to A. So here we have come to the conclusion that A transpose is equal to A. We have a name for this type of matrices, that is called the symmetric matrix. Symmetric matrix. Let us go for the definition. A square matrix A is equal to matrix Aij is said to be symmetric if A transpose is equal to A. If this condition is satisfied, A transpose is equal to A, the condition is satisfied, then we can say that the matrix is symmetric. Now move on to another example. Here we will go for matrix A is equal to 3 by 3 matrix 0 1 minus 2 minus 1 0 3 2 minus 3 0. We will go for the transpose again. A transpose is equal to, we know, row will come here as column, row will come here as column, so we have written A transpose. As before, we have to observe A and A transpose. Here there is little difference is there when you compare A and A transpose. Whatever elements are there in A transpose, the opposite signs, here 1 it is there in A, when it comes in A transpose it becomes minus 1. Here minus 2 is there in A, the same position in A transpose it is 2. So when you check, opposite signs are there. A, what is there, if A is having a particular element is positive sign, in A transpose it becomes negative sign. So what we have to do is just to take a negative symbol outside from A transpose. So when I take negative symbol minus outside, the matrix becomes 0 1 minus 2 minus 1 0 3 2 minus 3 0. Now you check this A transpose matrix and this A matrix. When you check 0 1 minus 2, here also A is also having 0 1 minus 2 in the first row. So when you check A and this matrix, both are having same elements. Since both are having same elements, we can tell that both the matrices are equal. That means A transpose is equal to, minus sign is outside, that we have to keep here minus sign, that is another matrix that is called as A. So the conclusion is A transpose is equal to minus A. These type of matrices are called skew symmetric matrix. So the definition goes like this. A square matrix A is equal to Aij is said to be skew symmetric if A transpose is equal to minus A. The condition again, A transpose is equal to minus A. So now we have learned two names. First one is symmetric matrix. Symmetric matrix condition is A transpose is equal to A. Next is skew symmetric matrix. The condition is A transpose is equal to minus A. So just go through it and keep the conditions in mind. Now we will move on to the exercise questions. The first question, that is question number 7 from your textbook exercise. Show that A is equal to, that is a matrix, 3 by 3 matrix, is a symmetric matrix. So we know the condition of a symmetric matrix. We have to recall it. If a matrix is said to be symmetric, then A transpose should be A. If this condition is satisfied, then we can say that the matrix is symmetric. So we have to write the given matrix. A is equal to the given matrix, that is 1 minus 1 5 minus 1 2 1 5 1 3. Then we will go for its transpose. 1 minus 1 5 will come, here it is in row, will change here as the column. Minus 1 2 1 will change here as the column, and 5 1 3 will change here as the column. So A and A transpose is written. And when you analyze A and A transpose, we can come to the conclusion that both are equal, same elements. So since A transpose is equal to A, we can say that A is a symmetric matrix. Now move on to the second question. Show that matrix A is equal to 0 1 minus 1 minus 1 0 1 1 minus 1 0 is a skew symmetric matrix. We have to prove that this matrix is a skew symmetric matrix. Simple. We have to recall the condition. Skew symmetric matrix condition is A dash or A transpose is equal to minus A. A transpose is equal to minus A. We have to take the same matrix A, it is written here. Then we have to go for A transpose, that is change the row and column. Then you can check when you analyze opposite symbols. So there is a 0, same, 1 here, minus 1 here, that is 1, means opposite symbols are there. What you have to do, take the minus outside. When you take the minus outside, you will get another matrix separate. Here it is. So when you check A and this matrix is same, so that is minus A is the conclusion. So A transpose is equal to minus A, therefore it is a skew symmetric matrix. So very simple question. In the first question we have to prove that it is a symmetric matrix. We proved that A transpose is equal to A condition, so it is a symmetric matrix. And the second question we have to go for a skew symmetric condition, that is A transpose is equal to minus A. That also we have proved here. So that is the conclusion of the first and the second question. Move on to the next question. For a matrix A is equal to 1 5 6 7, verify that A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. Simple. Just we have to take the given matrix A is equal to 1 5 6 7. Then we have to go for A transpose, that is equal to first row 1 5 will come here as the column, 6 7 will come here as the column. So A and A transpose is ready here. Just calculate A plus A transpose. A matrix is here plus A transpose is here. Just add the individual term, means corresponding terms. When you add, matrix addition is there. So 1 plus 1, that is 2. 5 plus 6, that is 11. Same way 6 plus 5, that is 11. 7 plus 7, that is equal to 14. Just let us recall the condition for symmetric matrix, that is A transpose is equal to A. Let us take here, instead of a single matrix, here A plus A transpose is there. Of course it is a single matrix, but calculation part, when you check, it is A plus A transpose. We have to take the transpose of this matrix, A plus A transpose, the whole transpose. 2 11, first row will come here as first column. 11 14 here also will come as next column. When you check both A plus A transpose and A plus A transpose, the whole transpose, both are same, A plus A transpose. So what the conclusion is, it is A plus A transpose is a symmetric matrix. Next question is A is equal to a same question, that is same matrix is given to you 1 5 6 7. Then A transpose we have calculated here. Just to substitute A minus A transpose, that is A minus A transpose we have take from here 1 6 5 7, that is 1 6 5 7. Then we have to calculate the subtraction of two matrices, that is 0 minus 1 1 0. Then we have to go for recalling the definition of skew symmetric, that is a dash is equal to minus a dash is equal to minus a. When you after recalling, just to take the transpose of this matrix, that is a minus a transpose the whole transpose of this matrix. When you write 0 minus 1 first row will come here as first column, 1 0 second row will come here as second column. Then what you have to do, as before, we have to take a minus common from this matrix. Minus, if you take outside, 0 remains the same, 1 becomes minus 1, minus 1 becomes 1, 0 becomes 0, same only, no change in zeros. So minus is outside. Well, after that we have to come to the conclusion that this 0 minus 1 1 0 is here, that is a minus a transpose, that is what is written here. So we have come to the conclusion that a minus a transpose is a skew symmetric matrix. So let us go through once again. Here we have to prove a plus a transpose is a symmetric matrix. What we have to calculate is, first we have to calculate a plus a transpose, then we have to go for transpose of this one, that is a plus a transpose the whole transpose. After calculating, we will come to the conclusion a plus a transpose the whole transpose is equal to a plus a transpose. So therefore it is a symmetric matrix. Next question, we have to prove it is a skew symmetric matrix. For that, what you have to do, a minus a transpose we calculated, same way a minus a transpose the whole transpose calculated. We have come to the conclusion that a minus a transpose the whole transpose is equal to minus of a minus a transpose. Similar to this condition, a transpose is equal to minus a. Therefore it is a skew symmetric matrix. Hope it is clear. Move on to the next question. Find 1 by 2 into a plus a transpose and 1 by 2 into a minus a transpose when a is this matrix, there is a 3 by 3 matrix. As before, we have to copy down a, same matrix, then we have to go for a transpose, a row will come here as column, 0 a b will come here as column. Same way, interchange the row and column, we will get the a transpose. Then we have to move for a plus a transpose. A plus a transpose. First write a matrix and next write a transpose. Then add the corresponding terms. 0 plus 0, that is 0. A plus minus a, that is 0. B plus minus b, that is 0. Minus a plus a, 0. So corresponding terms, when you add, you will get this answer. Then we have to go for calculating 1 by 2 into a plus a transpose. Means a plus a transpose is already here, we have to divide with 2. So 1 by 2 into a plus a transpose is equal to, just to keep 1 by 2 outside, means multiply it with this matrix. So if any scalar is multiplied with the 0 matrix, it remains the same, 0 0 0, same elements, it becomes 0 0 0, a 0 matrix, you will get it. Then we have to go for next part, that is a minus a transpose. We are going to calculate. We substituted the value a and a transpose. Corresponding terms you have to subtract. 0 minus 0, that is 0. A minus minus a, that is minus minus plus, that becomes a plus a equal to 2a. B minus minus b, minus minus b is plus b, that is b plus b is equal to 2b. Same way, corresponding terms added and we have got the final matrix, that is 0 2a 2b minus 2a 0 2c minus 2b minus 2c 0. Then we have to go for calculating 1 by 2 into a minus a transpose. Just to be multiplied 1 by 2 with this matrix. 1 by 2 into the matrix is here, 0 2a 2b minus 2a 0 2c minus 2b minus 2c 0. When you multiply 1 by 2 with this matrix, what you have to do is just to take it inside. 1 by 2 into 0, that is 0. 1 by 2 into 2a, that is 2 and 2 cancelled, you will get a. 1 by 2 into 2b, that is 2 cancelled, becomes b. Again 1 by 2 into minus a, 2 cancelled, you will get minus a. Again 1 by 2 into 0 becomes 0. 1 by 2 into 2c, 2 cancelled, you will get c. 1 by 2 into minus 2b, again 2 cancel, you will get minus b. 1 by 2 into minus 2c, 2 cancel, you get minus c. 1 by 2 into 0 will get a 0. So this is the final answer. We'll move on to the next question. Express the following matrices as the sum of symmetric and skew symmetric matrix. We have already learned the definition of symmetric, means A transpose is equal to A. Skew symmetric matrix means A transpose is equal to minus A. Here this question means they will give you a particular matrix. You have to split that matrix as, or you have to write the sum of one symmetric matrix and another skew symmetric matrix. So there is a matrix given to you 3, 5, 1, minus 1. So let us have a quick recall of some concepts. Here there is a matrix A, square matrix. We have to rewrite A as like this. A is equal to 1 by 2 into A plus A transpose plus 1 by 2 into A minus A transpose. Actually, this, when you simplify this right side, you will get A only. Means 1 by 2, if you take multiply inside, 1 by 2 into A, 1 by 2A, 1 by 2 into A transpose, that is 1 by 2 A transpose, plus 1 by 2 into A is 1 by 2A, minus 1 by 2 A transpose, minus 1 by 2 A transpose. So 1 by 2 A transpose and minus 1 by 2 A transpose will be cancelled. Finally, you will get 1 by 2 into A plus 1 by 2 into A. So half of A plus half of A, that is A. So here in the previous question, when you check the previous question, that is question number 9, we have calculated there 1 by 2 A plus A transpose and 1 by 2 A minus A transpose and all. So here 1 by 2 A plus A transpose, in this A plus A transpose is a symmetric matrix. Okay, in the previous question we have calculated that one, and the next A minus A transpose, that is a skew symmetric matrix. Okay, so when you write A as 1 by 2 into A plus A transpose plus 1 by 2 into A minus A transpose, remember A plus A transpose, A minus A transpose. In this, A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. If you are asked to calculate, or if you are asked to split a matrix into two, symmetric and skew symmetric, you have to calculate this way. 1 by 2 into A plus A transpose means you will get a symmetric, and 1 by 2 A minus A transpose is skew symmetric matrix. This is a very important result. Please keep it in mind. So we will take the given matrix as A and we will go for A transpose. Then first we have to go for symmetric matrix, that is, here we have already learned, that is A plus A transpose. So 1 by 2 into A plus A transpose we have to write for balancing this equation. So 1 by 2 into A plus A transpose, 1 by 2 into A is substituted, A transpose is substituted, then 1 by 2 into, when you add 3 plus 3 it becomes 6, 5 plus 1 that is 6, 1 plus 5 that is equal to 6, minus 1 plus minus 1 that is equal to minus 2. Just to multiply this 1 by 2 inside, it becomes 3. 1 by 2 into 6, that is 6 by 2, that is 3. Here 2 6 cancelled, that is 3. 2 6 cancelled, that is 3. And 2 2 cancelled, that is minus 1. So this is the first part. And when you move on to the second part, that is skew symmetric case, that is equal to 1 by 2 into A minus A transpose. According to the result, it is here A minus A transpose is skew symmetric. So we calculate 1 by 2 into A minus A transpose. Substitute the values 1 by 2 into A minus A transpose. Just subtract it. 3 minus 3 that is equal to 0, 5 minus 1 that is equal to 4, 1 minus 5 that is equal to minus 4, minus 1 minus minus 1 that is equal to 0. Then take this 1 by 2 inside, that is 1 by 2 into 0, that is 0, 1 by 2 into 4 that is 2, 1 by 2 into minus 4 that is minus 2, 1 by 2 into 0 that is equal to 0. So just come to the conclusion that symmetric and skew symmetric, we have to check, we have to verify it. Symmetric and skew symmetric, we have a symmetric matrix here that we have to write 3 minus 1, this matrix, that is a symmetric one. Skew symmetric is here, just a substitute here. When you add both, 3 plus 0 that is equal to 3, 3 plus 2 that is equal to 5, 3 plus minus 2 that is equal to 1, minus 1 plus 0 that is equal to minus 1. This is same as the given matrix A. Here it is, given matrix A. So the A matrix we have written as a sum of symmetric and skew symmetric matrix. That is the conclusion of our question. Now move on to the next question. That is 3 by 3 matrix is given to you. We have to write it as a sum of symmetric and skew symmetric matrix. We have to recall the concepts. That is, there is a square matrix A, and we have to rewrite A as 1 by 2 into A plus A transpose plus 1 by 2 into A minus A transpose. So when you rewrite these two, A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. So here when you come to the answer, we have to take the matrix as A. After that we have to go for A transpose. Then we have to first go for symmetric matrix, that is 1 by 2 into A plus A transpose. You have to calculate 1 by 2 into A plus A transpose. You write 1 by 2 outside, then A matrix here, its transpose is here. Just add the corresponding terms, that is 6 plus 6, 12. Likewise, you have to add all the terms and just multiply 1 by 2 inside, and the final answer we will get it as 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. So we have to move on to the next part, that is skew symmetric. For that, 1 by 2 into A minus A transpose we have to calculate. Just to substitute 1 by 2 into A and A transpose, subtract the corresponding terms, and you will get a 0 matrix. That is 6 minus 6 is 0, minus 2 minus 2, that is plus 2, that is 0. So all terms will be 0. When you multiply 1 by 2 with a 0 matrix, you will get a 0 matrix. You have to add symmetric matrix and skew symmetric matrix. Just add it. The symmetric matrix is here, skew symmetric is here. When you add it, you will get the answer 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. That is our given matrix, that is A. So here just keep in mind that if you are asked to write a matrix as a sum of symmetric and skew symmetric, you have to go for 1 by 2 into A plus A transpose, that is symmetric matrix, and 1 by 2 into A minus A transpose, that is skew symmetric matrix. Hope it is clear. Now move on to the next question. Next there are two questions, question number 3 and question number 4. Question number 3 is a 3 by 3 matrix. Question number 4 is a 2 by 2 matrix. So we have to write these two matrices as the sum of symmetric and skew symmetric matrix. Please try these two questions at home. Do it yourself. And we have two more questions left in this exercise, that is multiple choice questions. We'll have a look at these two questions once. That choose the correct answer in the following questions. That is first one, if A and B are symmetric matrices of same order, then AB minus BA is, four options are there: skew symmetric matrix, symmetric matrix, zero matrix, and identity matrix. So here conditions are given to you. A and B are symmetric matrix. As you know, symmetric matrix means A transpose is equal to A. That is the first condition. Another matrix B symmetry means B transpose is equal to B. So we have to check AB minus BA. So just to check AB minus BA, the whole transpose we have to take. AB minus BA the whole transpose is equal to AB the whole transpose minus BA the whole transpose. Transpose's properties we have to write, that is AB the whole transpose is equal to B transpose A transpose. We have studied the fourth property in transposes of matrices. Okay, BA the whole transpose is equal to A transpose minus A transpose into B transpose. So B transpose we have calculated here according to the property, that is B. A transpose is equal to A transpose is equal to A, B transpose is equal to B, that is BA minus AB. So BA minus AB, when you take a minus outside, it becomes AB minus BA. So the conclusion is like this: AB minus BA, there is a matrix. If you take the transpose of that matrix, you got negative of the given matrix, that is AB minus BA. That means AB minus BA is a skew symmetric matrix according to the condition. So the option A is the correct one. Move on. Next question, that is if A is equal to cos alpha minus sin alpha and cos alpha, and A plus A transpose is equal to I, identity matrix, the value of alpha is pi by 6, then pi by 3, then so another option is pi, and the last option is 3 pi by 2. So we have to take A plus A transpose, that is A is here, its transpose we have to take, equal to I, identity matrix 2 by 2 of identity matrix of second order, that is 1 0 0 1. Just add the corresponding terms. Cos alpha plus cos alpha is 2 cos alpha, minus sin alpha plus sin alpha 0. Add the corresponding terms, you will get 0 and 2 cos alpha equal to 1 0 0 1 identity matrix. Equate the corresponding terms, that is 2 cos alpha is equal to 1. 2 cos alpha is equal to 1. That means cos alpha is equal to 1 by 2. Bring 2 to the right side. Then cos alpha is equal to 1 by 2 means it is equal to cos pi by 3. So here alpha is equal to pi by 3. So the correct option is B, and we have come to the conclusion that B is our right answer. That's all for the session today. So as I have mentioned before, please make sure that you have completed all the works on your notebook and it is understood properly. And if there is any doubt, please feel free to call or send a personal message to my WhatsApp number. Thank you.